Hi, math students. This video is to help you with your upcoming checkpoint 1.11. Okay, so what you want to do is make sure that you have a piece of paper out so you can write down these notes with me. Or I also took a picture of this and attached it to the video so you can print it out and fill it in as we go along. The choice is yours, but make sure you write this down. These problems are just like the ones you're about to see on your checkpoint quiz. So you want to make sure you go through these with me first and then take your checkpoint. Okay, so a prime number. What does it mean to be a prime number? And you can pause the video at any time if you need more time to write, and then just push play when you're ready to go again. Okay, so a prime number is only divisible by 1 and itself. Only divisible by 1 and itself. So we're going to look at what that means here in a second. Make sure you have that definition down. Which of the following are prime? So 10. What is 10 divisible by? Most people are pretty familiar with 10, right? You can divide 10. Of course, you can divide it by 1 evenly. 10 divided by 1 is just 10. You could divide it by 2, right? 10 divided by 2 is 5. You could divide it by 5. 10 divided by 5 is 2. You could divide it by 10, that's itself, and you get 1. So 10 can be divided by many things, not just 1 in itself. It also has these ones. So 10 is not prime. It's called composite, by the way. If it's not prime, it's composite. Okay, 7. What can 7 be divided by? Well, of course, 7 can be divided by 1. Everything can be divided by 1, right? What else? I know it can be divided by 7. Everything can also always be divided by itself. Is there anything else 7 can be divided by? If you're not sure, you can use a calculator to check and just start dividing 7 by things. So what if I do 7 divided by 2? Nope, that has a decimal, it has a remainder. How about 7 divided by 3? Nope. 7 divided by 4? Nope. 7 divided by 5? Nope. 7 divided by 6? Nope. All of those had decimals. They all had remainders. So 7 is prime. It's only divisible by 1 and itself. That's what it means to be prime. How about 2? Okay, 2 can be divided by 1, and 2 can be divided by 2. That's it, because it's such a small number, there's nothing else in between there. So 2 is actually prime. Most even numbers are not prime because they can be divided by 2, but 2 is prime because the number 2 is itself. So that's kind of a tricky one that throws people off a lot. 25, well, I know it can be divided by 1. What else do you know about 25? It can be divided by 5. So right there, I'm going to stop because it can be divided by more than just 1 or itself. So 25 is not prime, it's composite. 84, of course we know it can be divided by 1. What else? I see it's even. I know it can be divided by 2. And if you're not sure, again, throw up your calculator and try it. 84 divided by 2, yeah, that came out even. So I can stop right there because 84 can be divided by more than just 1 in itself. It can also be divided by 2, and I'm sure probably a few other things along the way. So the only prime numbers in this list were 7 and 2. Okay, making a factor tree. So how do we make a factor tree? You start by making little branches, right? What are some things we know can multiply together to be 40? There's no right or wrong way on how to start this. I usually start, like I know 40 is even, so I'm going to say, okay, I know it's divisible by 2. 2 times 20. So there's my first branches. Okay, now 2, we just learned right up here, 2 is prime. So 2 can't go any further. It's just the end of the road right there. But 20, I can break up 20 a little bit more. I know 20 is 2 times 10. Okay, again, 2, that's the end of the road. We can't break up 2 anymore. It's prime, but I can break up 10 some more. 2 times 5. I know 2's prime, so that's stuck. How about 5? Can 5 be divided by anything besides 1 in itself? Nope. 5 is also prime, so that's the end right there. There's our factor tree. So you want to make sure you get to a prime number at the end of each branch. Okay, 36. I'll show you a little different way on this one. Instead of just going 2 times 18, I usually do that, but we could do, what if you know 36 is 6 times 6? All right, well, let's break up 6. I know 6 can be 2 times 3. How about 2? We know 2 is prime. That's the end of the road. How about 3? 3 is also prime. It can only be divided by 1 in itself. So that's the end of the road for both of those. And then the same with this 6 over here. We'd have another 2 times 3, and we just said 2's prime and 3's prime. So that's the end of the road there. 90. What do we know about 90? You can start this off lots of ways. Again, there's not one correct way to do this. I know 90 is 9 times 10. How about 9? 9 is 3 times 3. And we just said that 3 is a prime number. So that's the end of the road for those two. And 10 is 2 times 5. We know 2's prime and 5's prime. So that's the end of the road there as well. So that's how you make factor trees. There's not one specific correct way. You could have done this a lot different. You'd still end up with the same factors. Just real quick, you don't need to write this example down, but I'll just show you. Let's say you would have started this out a little differently. What if you did 2 times 45? There's nothing wrong with that. 2's prime, that's the end of the road. 45. Let's see, 45 is 5 times 9. Okay, I know 5's prime, so that's the end of the road for that. But 9, I can do 3 times 3. And then I know those 3's are prime. They're done. So look, I ended up with 3, 3, and 2, and 5. And here I have 3, 3, 2, and 5. So you still end up with the same prime factors no matter which way you do your tree. That's why I'm saying there's not just one correct way to do it. Okay, if they actually ask you what is the prime factorization of something, that means they want you to list all the prime factors. So here we made a factor tree, but the point of making a factor tree is to get the prime factorization, is to list out these factors. Okay, so for the prime factorization of 16, I'm going to start with my factor tree because that's just the way I figure it out. I know 16 is 2 times 8. I know 2's prime, so I'm done there. 8 is 2 times 4. I know 2 is prime, so I'm done there. 4 is 2 times 2. So the prime factorization of 16, by the way, I love circling these because then it's really easy to find the prime factors and they don't get confused with these other numbers we were using along the way. So the prime factorization of 16 is 2 times 2 times 2 times 2. You could also write that as 2 to the 4th power if you wanted to. That's what the prime factorization is. You make the tree so that you can write out the prime factorization. What's the prime factorization of 54? Okay, let's see, 54, what is that? That's 6 times 9, right? So 6 is 2 times 3, and I know those are both prime, so I'm going to circle those at the end there. 9 is 3 times 3, and I know those are prime. So I'm done. So the prime factorization for 54 would be 2 times 3 times 3 times 3. And if you'd rather, you could write it as 2 times 3 to the 3rd power. You can use an exponent if you want to kind of shorten it up a little bit. Generally, we start with the smaller numbers. So that's why I put 2 in front of all the 3's. And you don't have to, but that's just better formatting. Okay, and what's the prime factorization for 11? So what multiplies to be 11? 1 times 11? So 11 is a prime number. So the prime factorization for 11 is just 11. You could write 1 times 11 if you want, but that's just kind of silly because it doesn't help anything to add that 1 in front there. So if you have a prime number, the prime factorization is just itself. That's it. Okay, so if all of this made sense to you, you're good to go. Go ahead and take your checkpoint. You'll probably do great. If you still have questions on any of these, you need to reach out to me. Call, text, email, IM. The best way is to take a picture of the problem that you still need help with. Like say you need help figuring out which numbers are prime. Take a picture of this, text it to me, email it to me, and say, I need more practice with this. Can you give me some more problems to practice here? Or can we do a video chat? Can we talk on the phone? So reach out if you still need help. If this all made sense, go ahead and take your checkpoint now.